Okay, welcome to this week's M-Cubed seminar by Songyou Hong. I'm introducing him today since Rich is out of town. Songyou Hong has had a long career, and he got his PhD in 1992 from Seoul National University, and went to EMC from 1993 to 2000, where he worked on their regional spectral model and doing a lot of physics for that. From 2000 to 2017, he was a professor at Yonsei University. He went back to Korea to be a professor for 17 years, but also part of that time, 2014 to 2019, he was a KIAPS director, where he led the development of Korea's own global model that is now operational. And from 2021, he's been at NOAA Israel, and he's also an affiliate scientist here at NCAR. So he has an office at NCAR as well. So I think that's all I had to say, except I've known Hong for quite a few years. I know he likes hiking, and we've had some pretty good hikes. And he also cooks good Korean barbecue. So, welcome, Songyou, and I look forward to your talk.
Thank you, Jimmy. Also, I like drinking much. I drank a lot last night. I'm very tired. Yeah, thank you for coming. The tidal heavy rainfall mechanism, this is the topic I tried to pursue for a long time, since 1985. 1986, when I was a master student. But my PhD thesis also heavy rainfall mechanism of Korea, but never been published. It was rejected by Master Weather Review, I think, more than 3 times. And then finally, it became to be an article in the Spring of Nature book chapter, still in print, so that I'm going to share some of my interest for last 37 years. So the people are thinking is rainfall may changes. There's a record-breaking rainfall in the last months here in Boulder, more than 3 times than normal. Also, Korea suffers from the very heaviest rainfall in 80 years. So that is, this is the contents of the book chapter. It's in press. So I'm going to talk about the early numerical modeling studies using MM4 in US and Korea, and then uniqueness in heavy rainfall mechanism of East Asia. And then also I'm going to talk about some mechanism changes on the global warming. Okay, this is the, I think it is the first successful mesoscale simulation pioneered by the Dalin Zhang in 1986. That's the first paper. It's a Johnstown flooding, and then you can see that this observation and the measure high and measure low. And then Dalin Zhang was able to reproduce this mesoscale structure conceptual model following Fujita 1955, measure high and wake depression, measure low. So that they were able to reproduce this mesoscale structure in MM4 just using the conventional data. The major feature is rainfall jet and the measure high and measure low. So that is the time I was the second semester of a graduate student when I was 23 years old. So that I was very impressed by this paper, Dalin Zhang and his colleague. And then, see, for another pre-storm case, they were able to reproduce time series of measure high and measure low. Also, this is a model, this is observation. It was very remarkable to me. And then this is the progress of score line hourly, so observed and predicted. This is very impressed. I was very impressed. So that essential is that CPS is essential in organizing mesoscale features. CPS means a cumulus parameter scheme. That's without cumulus convection scheme is a bullseye problem. But that is the key. So in 1986, this is I was a third semester of a master's student. And then this is my supervisor, Professor Lee. Actually, he visited the NCA RL6 in the summer of 1985. And then he brought to the VEX version, I think helped by the Oliu Shea in NOAA. I think he retired now. And then Professor Son, who is a radiation expert, he was able to set up NCA graphic, but it's very difficult to run the model, so that he had a successful run for ideal data like island. And then I succeeded February 1986. This is my name in Korean. So that there, at the time, there is no manual, nothing. Just the MM4 program itself, without any documentation. So that I had to find out what is the input data, that how to make this input data. So that traced back. And in February, I was able to reproduce generate the grid, Lambert conformer, and the sigma p, and the simple initialization, and the other pre-process. So that April, it took about 2 months to get this. And then this is at the time, the no plotter. So that this is the Lelong grid value printed in a line printer. So that when I plot this Lelong grid, I was very happy because this was supposed to be the Lelong grid value. And then also mountain. So this is the mountain height of a Korean peninsula. So they got the global mountain data, and I was able to reproduce mountain data over the MM4 grid, which is Lambert conformal mapping. And this is, I think, a land use category. 7 was the water at the time. So that it was in 1986, February, I had to write this pre-process. Now it's all the geogrid or pre-processed WRF model. Then I was not sure if model is running, but it's successful to reproduce heavy rainfall data, heavy rainfall case, which is the grid size is 160 kilometer, 22 by 31. At the time, this 40-hour forecast took, I think, more than 5 days in the VEX 780. So I had to split the runtime into small pieces. And then ID7, it was the first semester of a PhD. I challenged the same work pioneered by the Darlin Zhang. So also there was a lot of heavy rainfall in the July 22nd, which is very much like a major beta scale. I think at the time, it is over 80 millimeter per hour. Maximum precipitation was over 400 millimeter per day. So I think there are more than 300 people died for this single case heavy rainfall. So that when I analyzed observed data, there was a major low and a prefrontal major low and a major high, but didn't see wake major low in the trailing stratiform region. So setup is very similar to Darlin Zhang and Fritsch, 1986. But by doing many experiments, then 20 kilometer MM4 with MPS only, without cumulus convection scheme, was able to reproduce rainfall successfully. with this inclusion of a Couentis and Arakawa scheme or Gray scheme at the time, actually maximum precipitation was less than 50 millimeter. So the very widespread. Then I have a question to me, what's the very different sensitivity from this case and also subsequent studies over the United States that was done by the Dalin Zhang and his colleagues. So that also, this is the precipitation of the, I think, a single point observation as a 3-cell, also control model, also as some cells. And that this is a time series sea level pressure is increasing, indicating kind of major high. So that all the sensitivity experiments, I follow the Dalin Zhang's study, generally follow his, where CPS is employed. But here, CPS is taken out. Also, excluding evaporative raindrop, it did not produce multi-cell, it's just a single. So that evaporation cooling is a major mechanism for multi-cell structure. And then here, ice microphysics is found to be responsible for suppressing numerical point storm in this case, where CPS is responsible over United States, that is a study. Then we can think about what's the difference in mechanism. And then this is the cover of my PhD dissertation in 1992. I just cartoon schematic. So that major high and cold fill appear, but no wake load that are generated by rear inflow jet. Also, problem in the Dalin Zhang study, cisco-like numerical point storm is not a major issue over this here, in this case. Also, multi-cell structure with the cold fill forcing, so-called RKW theory, I think Rotner, Klemp, and Weissman. There is a major mechanism for reproducing the multi-cell structure. Also, later, I figure out there is a paper in the BAMS, Georgie, Bryan, and Fritsch, published that there is a kind of 6 kind of instability, so-called most adiabatic unstable layer. That means saturated, most adiabatic, but if we have a continuous forcing near the surface, then this saturated profile becomes unstable. That is actually, I submitted the paper many times, then always rejected, and then also provide some observation in the Korea, have a very saturated up to freezing level, but eventually I gave up. But the MM4-based microphysics scheme without convex scheme was operational at Korean Military Administration until 2000. And then it was replaced by MM5 system in 2000. Yeah. Then I gave up. And then challenged again after going back to Korea in 2000. Very luckily, reanalysis data was available. So that reanalysis data in mid-1990s accelerated the numerical modeling study, which can be used illustrate the mechanism of geographically different regions. So that it's pretty easy to set up the model of a different region. Nowadays, we all know that CPS needed even at very high resolution, but we can use this model precipitation to identify the precipitation mechanism. So that I challenged it again after 10 years, my graduation. And then we used that this, in the reality, there is no such a thing, but in the model, there are 2 processes, microphysics scheme and the cumulus convection scheme. So that in the very high resolution, the role of a CPS is small, but it's given in the reanalysis, same model and the long-term analysis data set, also they there is a 6-hour forecast rainfall from the real data. Then we can identify the mechanism by looking at the portion of precipitation from CPS scheme and the MPS scheme. So now I use this CPS scheme is so-called now is a SAS scheme in the GFS. Actually, convex parameter scheme remove the cape so that stabilized column. MPS scheme is the remove supersaturation, so that we can identify the characteristics by looking at the portion of precipitation, whether it's from the CPS or MPS. So I did the experiment, many experiments, but they're just excluding one of each, CPS or MPS. Okay, then now we were able to set up the model domain anytime, so that very same domain, same latitude, and this is over Kansas and Nebraska here. I just observed the precipitation. This is a maximum precipitation is a 55 millimeter, and then this is without CPS only, without MPS. So that broad structure you have there's a missing, but it's a majority is observed. But the problem is here. When the CPS was taken out, the maximum precipitation is a 605 millimeter. That is the reason why CPS is essential over the United States. So we cannot make the precipitation forecast with this bullseye, but that is not the problem of Korea. This is a maximum precipitation is 371 over Seoul, and then this is without CPS, MPS only. We have a very well elongated precipitation band. Maximum precipitation is still less than what was observed. And when we take our MPS, actually totally much smaller. We cannot use this for forecast. So that very different sensitivity over two different regions. So that try to identify the finding in the literature, so that this is my some speculation. Significance of the Cape and strong synoptic environment pronounced over the significant Cape over US, also a strong synoptic environment over Korea. Then how can we define the synoptic characteristics? Very fortunately, we have now reanalysis data is available, so that we have analyzed the climatology 79 to 2001. Geographically, same latitude, and the maximum precipitation over Korea, maximum precipitation over Oklahoma, Kansas. You look at the climatology, the region. Wind speed, I think black solid line is Korea, and this is a dotted line is over Oklahoma. Very interestingly, moistatic energy, which is a cape, indication of a cape. Over Oklahoma, Great Plains, significant amount of cape, but over Korea, neutral or almost zero. And then our relative humidity is more moist over Korea. Then we can identify this Korean with strong baroclinicity, less cape, and moisture. And then look at the portion of convective precipitation, so that local instability driven or the synoptically driven. Then look at the convective precipitation ratio over total precipitation. Then you can see tropics over the much of United States all becomes to be mostly from the cumulus convection scheme, which is a locally driven instability. So much of the ocean, but over Korea and some part of mountain region, this area is only about 50%. Other than this area, mostly red. So I think we can see that if we have the scheme developed at the time, with this of Great Plains. If we bring the scheme into Korea, it automatically works. And look at the 1 month. July is the monsoon period in the Korea. Then you can see that Korea is about 50%, also western part of Japan. Other than these areas are all red. That means that local instability, cape-driven precipitation. Actually, there are many international workshops in East Asia, and then Japanese and Korean scientists agreed to the uniqueness, something different from the precipitation over United States, something different from we learned from the textbook. But Bilko at the time, Bilko is also participant. Bilko said, oh, we cannot exclude CPS scheme because Bilko is from Taiwan here. Yeah. I clearly remember the statement. So there is long-lasting argument since 1990. And also another 10 years passed, then we don't know because of the structure, internal structure. After 10 years, Professor Son analyzed satellite data. Satellite data become to have a precipitation radar, PR data. So that he followed very same setup of Oklahoma and Korea, just like what I did in the numerical experiments. And then they used the TRIM TMI. This is little south because this is the northern boundary of TRIM data. And drive the product and compare to some for 10-year period. And then this is the US-Korea, US-Oklahoma is red, and Korea is black. This is light precipitation, B, C, D is a heavy precipitation. You can see that, and then x-axis is storm height and the PDF. So that if you look at the heavy precipitation, red one is a maximum of about 15 kilometers, which is about tropopause. But the black, about 7 kilometers, much lower. That means warm type precipitation is a major mechanism of Korea, and the cold type is pretty much dominant over the Great Plains or Oklahoma region. So that this one indicated the hint why significant different sensitivities for previous and study over Korea US for past 30 years. And then also you can see warm and moist layer up to the freezing level with a relatively weak cape on the strong monoclinic environment. That is the characteristics from this satellite data. And that is the hypothesis I proposed in early 1990. Then it took another about 20 years to get the confirmation from the observation. And then Professor Son further analyzed this I think cluster analysis. And then type 1 is a cold type. So they indicate well-developed convection system, mainly inland China. This is most dominant. And the warm type process appear to be a low-level moisture convergence over mostly in the oceanic region. So that they analyzed the reanalysis data. Also, they confirmed that moist adiabatic near neutral conditions. And this is obviously in real world, various types of precipitation coexist or geographically different region, but in the research, they focus on the high impact weather in the research community. In US, square line type MCS having a major attention. Korea, cloud cluster type is the major subject. So that in reality, it can always coexist at the major high impact weather as a different mechanism. Okay, then next question is whether this mechanism is a change under the global warming or not. So that I asked one of my students, actually co-author of this book chapter, so that we have a global, we used the global atmospheric analysis data set, so that using the NCEP DOE, run the global model for 30 years. And it's the same model, but very high resolution is about, I think, 20 kilometers over here. Then we can identify the change in the mechanism by looking at the convective precipitation and the microphysics precipitation. Then we examine the enthalpy predictability and also ratio of convective rain over total rain. And then we try to identify global hotspot for changes precipitation mechanism, so that this is the kind of hotspot over here. Red one is losing the accuracy on the global warming. The red one is a gain. Increase the accuracy by suppressing local instability. Also, we submit the paper to Nature. It was rejected in the final, very last round. So that we further try to look at the change mechanism, so that this is kind of losing the accuracy or the increase of local instability. And this area is the other way around, yeah. So that accuracy in predictive precipitation dropped over East Asia, and the skill of Brazil was benefited. Then we further analyze using the ERA data recently, whether it is what happened in the United States and also Korea. This is the United States, and this is Korea. I think this is 79 to 2020. It's about 40-year climatology. That this is a ratio of cumulus convective rain over total rain. So that absolute value is still very small over Korea, and over ocean region is large, but over United States, much dominant convective rain. So that, and then we further analyzed this, I think, UF analysis, so that whether this convective rain ratio climatology is changing with the time. And then this is the East Asian region, and this is the US region. You can see that East Asia, there is a slight increase of local instability. United States, I think quite a very significant, discernible decrease of local instability. So that also another feature is that we are having a more fluctuation, yearly, annual variability. But here I think that absolute value is still smaller over East Asia, but the United States from 1985 to 2010, very recently, then there's more fluctuation, but general decrease. That means maybe some synoptically driven precipitation mechanism is increase. I think it seems to be true. I saw there some cloud on the Boulder last few months, pretty much overcast instead of isolated thunderstorm. I saw many times. So this might be indicated there. So that East Asia has experienced a general increase in the CIRES with enhanced internal variability in recent years, but US undergone the decrease in the CIRES. That means in terms of precipitation forecast skill, US may be benefited, but Korea is losing the skill. Yeah. I think I already finished my talk. Yeah, I think then what is the future direction to overcome this predictability skill? I think still we have the issue in the role of cumulus parameter scheme. So that this is the unstable region and stable region. When the grid is saturated, micro scheme is activated and precipitation. And then also when the local instability, the CPS scheme has to increase some vertical motion so the micro scheme take it over. But the transition from the CPS to MPS is very tricky. So this is, for example, role of a CPS scheme when the grid is locally unstable. Then suppose complex scheme have induced over the motion so that it can be saturated and micro scheme take it over. But this is a very tricky, but still questionable how to is it correct or not. And then this is my last slide. So the future direction, I think I say fundamental question, insight on role of a CPS scheme at higher resolution. I think existing scale of parameterization, so-called scale aware or the scale adaptive CPS scheme kind of hardwired because all the scheme has come delta X function. And then it has to be keep revised because large scale circulation change it on the global warming, then incorporate the change in the large scale circulation into the parameterization. That needs to be pursued. Also thinking correct coupling of CPS and MPS. That means how to, I don't know what is the correct way is. Then some scheme has a detrained, some scheme has kind of a different approach. But still, this is, I think, not settled down. Also, other physics component, how the hydrometer treated PBL or radiation. And also, this also need to have a question, fundamentally, so that correct coupling of physics forcing to dynamic forcing is different from the MPAS and the FV3. I don't know which one is more correct. Yeah. Anyway, I think fundamental research is the direction. Still, fundamental research is the direction to understand or to improve the skill of prediction and forecast. Yeah, that's it. Yeah, thanks.
All right, any questions? Or online? Okay. So one way to answer these questions are with high-resolution cloud resolving models. And it seems you should be able to distinguish these types of systems, the heavy rain Korean type and the convective US type, in detail at some resolution where you can trust, if you can trust the cloud resolving models. So that seems to be one area this research could go, is to get a fully resolving model.
Yeah. I think there's a question, is it fully resolving or not? I think WRF model, CPS scheme is taken out. Most research paper, CPS scheme is taken out for the grid size smaller than 3 kilometers. 3 kilometers widely used. And 3 kilometers CPS scheme is taken out, but it's not the way, I think. I don't think 3 kilometers is a fully resolve the motion as in the nature. So in principle, CPS scheme is needed until at least the LES resolution. Yeah. So we take out the CPS scheme because inclusion CPS scheme actually harm the forecast.
was wondering if you could say a little more about the last future direction line you have, because you mentioned FE3, and FE3 does something different than pretty much all the other models right now that are out there.
Yeah, I think.
And in terms of coupling physics to dynamics.
Yeah.
And you can show that it's only first order accurate, and it produces a lot of noise in the solutions if you don't damp heavily.
Right.
So I think we know what the better way is, at least if we look at what most modeling centers are doing. So
I don't say. I mean, or in other words, there is a way to continue to improve. But the most, I think, development or the finding a new approach, I think it was available around 2010. And I don't see some papers after that. For example, new numerical scheme. When I was at university, I chose some numerics paper, and every year I could find it after 2010. So that means people think, oh, this is correct, but we don't know. There should be a way to further improvement. I think this is also another one. Scale awareness or whatever, 3 kilometer, 1 kilometer resolution, all the papers doesn't include the CPS scheme. But in principle, it should be, I think. Good. Okay.
Another thing people have noticed is you do often need CPS schemes at down to 3 kilometers just to trigger convection at the right time, because if you leave it to the microphysics, it's too late and then too strong. So there is an argument to keep them even at resolutions people might not be developing them for. And you need some more scale-aware types of schemes to do that.
Mm-hmm.
Do you have any comment on scale? You mentioned something on scale-aware schemes, but
the scale scheme I developed is that CPS scheme is needed up to the resolution, I think 25 meter, which is LES.
Oh.
Resolution. Wow. I think basically this is the key. This is kind of one of the approach. CPS scheme just to generate the large-scale motion, for example, over the motion. Then all the other process will be taken by the microphysics scheme. Mm-hmm. That could be another way. I don't see any papers, but Yep.
There's one in the back.
Hello. I just wanted to ask, maybe in a bit more detail, where you touched on, firstly, if you could just, I suppose, repeat about this local instability. Mm-hmm. I don't think I fully caught that, but could you try and firstly define it? Because what you seem to mention towards the end there is that potentially in these areas where there's these kind of enhancements in this local instability, or at least under these climate change scenarios where the local instability might be increasing, then when you run this kind of model, the predictability seems to kind of be decreasing.
Actually, synoptic scale instability, like large-scale motion, for example, large-scale convergence, increase the over the motion, create the cloud and precipitation. There is more likely upper-level jet or low-level jet have a convergence region in the surface. Local instability more like a thermodynamically driven, like an isolated thunderstorm. So that in that case, this is very localized, so that model grid forcing cannot capture that activity. So that for the local instability, we assume that suppose have a pretty much of a cape Then we predefine adjusted profile. That is the role of a cumulus parameter scheme. Cumulus parameter scheme doesn't check this kind of evolution. So check the before the onset of precipitation and then after the precipitation. So that there is a much more uncertainty in the precipitation from CPS scheme.
Okay, I guess then continuing on, one of the things I noticed which was quite interesting was that you noticed, for example, over the Korean Peninsula with the kind of general decrease in maybe the kind of expected forecast quality there, and this maybe association with this enhanced local instability. And kind of recently with some of these kind of turbulence or inertial instability studies, what I found quite interesting to kind of compare with some of the work that you showed is that there have been these kind of increasing trends of more kind of these mesoscale latent heating regions, or these regions of enhanced inertial instability over the Korean Peninsula, and also really interestingly over the Western Atlantic region, where you kind of highlight once again this kind of enhanced region of a much stronger kind of, or at least this particular signal of a kind of stronger like local instability. So I also found it quite interesting that these regions that you're highlighting are these regions that are expecting or at least experiencing really significant enhancements and also upper level inertial instability, which might be related to these kind of convective weather storms. So I suppose the point being is that it's kind of really your work here kind of really nicely ties together with some of this kind of more turbulence and inertial instability research. So that's it.
Yeah, I think so. So that is interestingly, after 2010, I think more fluctuation, so that more unpredictable. So, but it's quite decrease over United States. It's interesting.
I was wondering what the dashed and solid lines were on this.
I think it's let's see. Actually, I forgot this. Yeah.
But you're saying the US is becoming significantly less convective.
So that I think this is just my prejudice. I saw many of precipitation these days, this year. Yeah. The cloud is all cloudy, and more continuous precipitation, long-lasting precipitation. It seems to be more like a synoptically driven.
Could it be related to the amount of moisture increasing?
Yeah, I don't know.
It's not clear why they go in different directions.
I don't know. So that is we have a global warming in general, then it may be overall increase of instability, then the impact is different for geographically different regions.
It's really not a question, but a comment. You kind of try to present a kind of a historical perspective. When I think about the, let's say, last 40 years of research in weather prediction, and you brought Dalin Zhang when he was here at NCAR and kind of his work, I think the key aspect is the organized convection. I mean, if you think about Arakawa-Schubert, the argument that they have, there is really no organized convection. What Dalin Zhang showed is that in a 15, 25 kilometer model, which is still hydrostatic, MM4 was hydrostatic, you can have parameterization of convection working together with a hydrostatic model and end up producing organized convection. I think that was the first time. He was actually at NCAR when he did that. Yeah. And so for these heavy rainfall cases, I'm pretty sure the organized convection is the key. So I would actually argue that a kilometer or 3 kilometer model should do okay for those systems. the development when you go over land from shallow to deep convection is the key, and that's maybe why you need shallow convection parameterization together in convection permitting, 2 kilometer, 1, 2, 3 kilometer grid lengths. I think that would be one way to understand what's going on. And of course, in the future, we will have larger dissimulation NWP, and presumably, but then of course there are other aspects. Data assimilation is a big issue. I don't think we know how to do it in LES environment, am I right?
Yeah.
So, anyway, so.
Yeah, I think that I totally agree. Yeah.
Okay, I think that's it. Songyou Hong is, of course, a long-term resident in he has an office for the top of the stairs in FL3.
Yeah.
So anyone can go by and talk to him. He's there a few days a week.
Okay.
Right.
Okay, thank you.